Good day everyone. Good day panelists. We are Group 3 from Brother Flavius and our science investigatory project is about automated vertical gardening system using retroreflective sheet and LED light as alternative light source. I am Idsi Nunez and I'm here to introduce to you the background of the study. After trying and seeing the different types and configurations of vertical hydroponic gardening, we thought about why not try another automation approach. Automated vertical gardening because in our generation today, many people love to take care of plants and build a nursery but they have problems with their time and time they will allocate to it. And nowadays, the work provided by the automated vertical garden is easier because of space saving and maintainable expansion. The purpose of vertical garden is also to improve air quality that has natural air filters that can help establish a cleaner climate. We thought of doing this research because we noticed from the vertical hydroponic setup at our greenhouse in school that the plants from other layers are not fairly getting enough nutrients from the sun. Even if there are used plants that no longer need the sun, those are just a few. And the basic plants we see for the vertical garden really need a vitamin D. Without the sun, plants will not get the necessary food needed to grow, reproduce, and survive. We chose automated vertical garden by solar power because the advantages are it is the crucial future production method in the move to clean energy and has its low maintenance cost. The main advantage is solar energy creates clean, renewable power from the sun and benefits the environment. Sunlight reflectors are retroreflective sheets that can allocate nutrients to different plants in the setup of bilayers. And since the retroreflective sheet for the sunlight nutrients of the plants has been tackled, there is no problem at night because there are LED grow lights to be an alternative light source. LED grow lights run much cooler than high-pressure sodium lights or HPS, resulting in an obvious set of benefits for the indoor nurseries. LED grow light units typically comes as all-in-one fixtures, which are easier to work with in tight spaces, which really matters to the automated vertical gardening of researchers. They can also be placed closer to plants in confined areas with very little risk of heat damage.
The aim of this research is to prove the outcome of the alternative light source. The effect of the retroreflective sheet can make the plants grow faster than usual use of gardening. The precise growth of plants can be observed through the quality of the air. The retroreflective sheet can give the plants amount of nutrients and light that reflected. The efficiency allows the distribution of light in grow room. The light strips are used in nighttime. It can increase the lighting wavelength of the plants that need optimum of chlorophyll production. Lastly, the effect of the light strips at night time can increase the turgor pressure of the cells and drives the enlargement because it's a nighttime, it can still work by its low.
For the significance of the study, our main target is to help busy people to have lighter work, to lessen the hassle of an individual in maintaining the plants, and further simplify people's work. Everyone can benefit from this study, the people, the society, and even the future researchers. Additionally, now that a pandemic is happening, gardening is one of the activities that can keep them well, relaxed, and many more. With the help of retroreflective material, the plants get a sufficient supply of solar heat. Because the problem in this vertical gardening project, most of the nutrients are received by the upper layer, while the lower layer does not get that much sunlight. So the researchers came up with this retroreflective light that will help in giving equal sunlight to all. Some people in the community can make a good livelihood out of this because the growth of plants is twice faster than normal gardening. Because even though there's no sunlight, the LED lights can give the plant the solar heat they need to gain more nutrients. That's all, thank you.
This study aims to show us an alternative way on how to make planting system easier. Automated gardening provides us a new way to grow plant indoors that is less hassle and not time consuming. The growth of the plant is twice faster than manual watering. It also produces organic vegetables. Plants can still grow even though sunlight is not present. LED lights provide heat to gain nutrients in the nighttime, can be positioned so that water is more effectively targeted where it is needed. Our vertical garden cannot do all the work. That is why retroreflective light and solar panel helps in giving equal sunlight to upper and lower layer for them to grow effectively. However, vertical gardening can be expensive due to technology costs and construction. It requires big amount of electricity for plants to grow. This can also lead to potential job loss to the farmers, since this system is much reliable due to making them work faster and effectively. In addition, our automated vertical gardening is efficient, reliable, and eco-friendly. Vertical gardens are natural air filters that help establish a cleaner climate and make our planet habitable.
Our group had thought to build an automated vertical gardening system by using the materials PVC pipes, Y connectors, PVC adapters, solar panel, solar charger controllers, solar panel battery, rocker switch, USB step down, buck converter, USB cable wire, Arduino Uno board, 5V ray module, 12V solenoid bulb, soil moisture sensor, 3M grow light strip, LDR sensor module, flexible hose and pipe reducer. The retroreflective sheets are placed with the solar panels so when the sunlight hits the retroreflective sheets, it will be able to give the plants the sunlight nutrients it needs. The researchers will first gather and set the materials needed. Next is to construct the vertical garden setup, then place the retroreflective sheet and LED lights, and lastly observe and gather data on a daily basis, which is to set off the pipes. Next is to construct the frame, the use of PVC pipes, Y connectors, and PVC adapters. Next are the water hose placements, to keep the plants growing with the tube emitters across the top of the panel to drip water for the plants. Other materials such as Arduino Uno and sensors are for the programming and coding devices used to activate the automated vertical gardening system. This is the structural design and setup of the system with PVC pipes, reflective sheet, LED lights, vertical pipe stand, soil moisture sensor, and flexible hose.
In order to create a high-quality product, the researchers use high-quality materials. Using high-quality materials can cost a lot of money, starting with the solar panel, its charger controller, and its battery, costing a total of 1,798 pesos. The researchers also use rocker switch, USB step-down buck converter, USB cable wire, Arduino Uno board, 5V relay module, 12V solenoid bulb, soil moisture sensor, 3M grow light strip, and LDR sensor module for the technical materials, and flexible hose, PVC pipe, pipe reducer, and PVC adapter for the container and other materials needed to complete the product. With that many materials to be used for the product, the total cost is 4,134 pesos. It is a big amount of money for students, but having 6 members to contribute made it easier for the researchers to buy the materials needed and to complete the product, costing 689 pesos needed to contribute per member.
For the schematic diagram, the connection starts in the solar panel. The solar panel is connected to the solar charger controller that's also connected to the battery. The solar charger is important so that the flow of the electricity is direct to the battery. The output of the solar charger is connected to the rocker switch. The negative charge of the main switch is connected to the buck converter and the 2 relays. The buck converter will convert the volts of the battery from 12 volts to 5 volts. Without this buck converter, the Arduino will explode. The positive charge from the buck converter is connected to the solenoid and the grow light.
Then the relay will turn on and off the solenoid programmed into the Arduino. Then the solenoid is the one that turns on and off the flow of water in the system. Next is soil moisture sensor, whose role here is that it will take the value of each layer, So each layer has a soil moisture sensor which will give an average. It will be based on the average of what value it will irrigate. Usually, when the value is less, it sends a signal to the relay to turn on the solenoid. Lastly is the LDR or light dependent resistor, which detects whether there is a presence of light or not. Then, if there is no presence of light, it gives a signal to LED grow lights to turn on.